so today we're going to talk about properties of trapezoids and kites, very similar to yesterday's with rhombuses and rectangles. Today it's trapezoids and kites. And some of these properties are going to be very similar to what we did yesterday. Okay, they have some of the same properties. The kites and trapezoids have some of the same properties about them that rectangles and rhombuses had. So that's what makes this next test a little bit more difficult, is because you have so many things that are so similar, yet they're just slightly different from time to time. And that's why I told you from day one of the lesson or the chapter, let's try to make sure we kept up and didn't get behind, because you try to jam all this stuff in a day or two, and it's going to be difficult. So remember, your test is Monday. So if you're not caught up, make sure you get caught up this week, and this weekend you can spend time using your review to be ready for your test. All right? So today, trapezoids and kites. First of all, we want to make sure we understand the terminology and the language that goes along with a trapezoid. Okay, this trapezoid I've drawn as what kind of a trapezoid? Anybody notice? Isosceles trapezoid. Good. The base angles, P and A are base angles. They're going to be congruent. And also T and R are base angles. And remember, we had this conversation before. Bless you. Someone might say, so all the angles are base angles. Well, yes and no. They come in pairs. And so the bottom two, well, if it's sitting like this, if it's sitting on one of its bases, the bottom two are base angles, and the top two are a pair of base angles. But T and P, angle T and angle P, these two are not base angles. Okay? They're consecutive. And because these lines are parallel, then these base angles do what? Yeah, they add up to 180. They are what kind of angles from chapter 3? They're supplementary. They're called same side interior. They're on the same side of the transversal, and they're inside the parallel line. So the same side interior. Okay, very good. All right, I'll pause for talking and let you copy, and then we'll talk. All right, again, this is called the isosceles trapezoids theorem, and it simply says base angles of an isosceles trapezoid are congruent. Remember, the definition of isosceles trapezoid talked about these sides being congruent. The non-parallel sides were congruent. That's the definition of an isosceles trapezoid. So in that definition, we don't have anything talking about the angles. So then, because we could make triangles and prove these angles congruent anyway, there's a theorem. Remember, theorem means a statement we can prove to be true. There's a theorem that just says, hey, because it's an isosceles trapezoid, these base angles have to be congruent. Okay? So that's one of the things you need to remember about isosceles trapezoid. Not true about all trapezoids, just isosceles trapezoid. Another theorem, actually there's two more here. And the picture of my house, we talked about that yesterday, so I'm going to discard that. Move this up so you can copy it down, then we'll talk about it. Diagonal of an isosceles trapezoid, very similar to a rectangle. The diagonals of an isosceles trapezoid are congruent. Okay, so if I just quickly drew an isosceles trapezoid here, and we may have to use our imagination. Okay, what this is saying is, remember, the diagonals can connect non-adjacent vertices. Those diagonals are going to be the same length. Okay, not true of all trapezoids, only true of isosceles trapezoids. Okay, now yesterday I said that if we had congruent diagonals and we had a rectangle, and I think I may have not said that clearly enough. What I meant to say is, if we know we have a parallelogram, bless you, we know we have a parallelogram and we make the diagonals congruent, then it has to be a rectangle. Okay? What I meant by that is, say if I know that these two sides if I know these two sides are equal and these two sides are equal, then Remember the properties of a parallelogram said if opposite sides are equal, then it has to be a parallelogram? Alright, so if I know the opposite sides are equal, then I know that has to be a parallelogram. If you look at that, I kind of do have an angle on it, don't I? I didn't draw a rectangle there, did I? Okay, so if we can pretend that's a parallelogram, and I took this and I straightened these up, slid the bottom over a little bit and straightened that up, so that these lines here were congruent, then that parallelogram would become a rectangle. That's what we were talking about yesterday. And we used, I did this project with 6th period, kind of learned from some of our flying tactics. And I did it a little differently, 6th period. But anyway, you notice they made a pretty good looking rectangle here, didn't they? Okay? So we used this concept here slightly differently than what you had done. Okay? And so I appreciate you being my guinea pigs, and I went through it, didn't quite develop the way I had pictured in my head, and so during my conference I spent some more time thinking about how I'd like to tweak it, and so I made some adjustments, and it went quite a bit better. 6th period, not that it matters to you guys. But anyway, the difference here is this is not a parallelogram. Whoops, let me delete that. This is not a parallelogram. It's a trapezoid. And if I have a trapezoid and I know it's a trapezoid, meaning I only have one pair of parallel sides, and then I discover that the diagonals are congruent, then I know it has to be an isosceles trapezoid. Okay, so very similar to yesterday's rectangle. The difference is what we're starting with. Here we know it's a trapezoid, and here we knew it was a parallelogram. Two different shapes. Okay? Diagonals of a kite are perpendicular. Very similar to a rhombus, right? Diagonals of a kite are perpendicular. In fact, when I have to draw a kite, let me show you what I do on the board. I start out with my long axis, okay? And then I draw this one in. And let's say I do this. I made them perpendicular, but I didn't create a kite here. So I cheat. When I grab this, there you go. When I grab this and move it around, I can line this arrow up now right in the middle of that line. It could be there, it could be anywhere in here. Okay? As long as I don't hit the middle of this line, that would create a problem if I hit the middle of that line, because then I'd have a rhombus, which I can't have. Remember, opposite sides of a kite can't be parallel. So anyway, when I draw this, I just make sure that I have perpendicular lines, and I make sure that this line intersects the other line right at its midpoint, and now I have the diagonals of a kite. And so if I connect these to make my kite, I'm using this theorem to make my kite. I'm using the fact that I know the diagonals of a kite have to be perpendicular to make my kite. And so if you're asked to draw a kite, you could start out the same way. You might do it freehand, you might use a ruler or a measure, but make your lines, your diagonals perpendicular. Okay? Try to make the long diagonal go through the midpoint of the shorter diagonal. And then when you draw these sides in, you don't get in a hurry. You draw those sides in, you have a fairly decent looking kite. Okay? So just something to think about. And I'm just applying this theorem right here that says diagonals of a kite have to be perpendicular. Any questions on those two? All right. What's tricky about this problem? Anybody have a suggestion? We're doing odds today, so I'm going to throw a bunch of evens up, for example. Anybody have a suggestion what makes this problem a little bit tricky for some people? I'm sure it's not you, but maybe my other class. Caleb? I can hardly read it. Well, here, I can fix that.
That's 111, right?
There, can you read that now?
It's sideways.
It's 111. Yeah, that's it exactly. It's 111 degrees. And then these other angles are not 1, 2, and 3 degrees. They're angle 1, angle 2, angle 3. Okay? And what kind of a trapezoid is it? It's isosceles. But the point I want to make was, yeah, let me move these back out of the way, because they're not going to rotate anyway. The point I wanted to make was, is this isn't sitting the way we normally like to see a trapezoid sit. And sometimes what I suggest to you is take your book and rotate it around. You can't all just grab the writing on your paper and do this to it. So take your book and rotate it around. If it's a test and you're confused, take your test, rotate it around. Make it sit the way you'd like to look at it. How many of you solve an equation really preferred, at least for a long time, to have your variable on the left? Okay? Probably all of you did at some point. Before you solved enough, you got more comfortable with it. So take advantage of your ability just to rotate your paper around and look at that the right way, the way you're used to seeing it. So which are my base angles up here? Name a pair of base angles. 1 and 2. So I would agree with that. Angle 1 and angle 2 are base angles. What's that mean about them?
They're both equal the same.
They're the same. They're the same value because it's what kind of a trapezoid? Isosceles. Good. Now name another pair of base angles. Yeah, 111 and 3. And so that means they are what? They're congruent. So what's the measure of angle 3? 111. I'll write up here and start down there. It's easier to see. Right now, I don't know either of 1 and 2, do I?
Yes, you do.
Okay, good. Some of you know what to do. But what I meant to say is it's not written up here, is it?
Oh, no.
So we have to use some knowledge to figure out the connection. So, RJ, would you tell me, please, the connection you have that helps you find, say, angle 1?
Well, it has to equal 180. So just subtract 111 from 180.
Okay. What he's saying is that these two angles, this one and this one, are adjacent, right? They're between the parallel lines. They're on the same side of the transversal, so they are supplementary, meaning they add up to 180. And so he's saying measure of angle 1 plus 111 has to equal 180. And then he just did the subtraction in his head. What'd you get? 69. So measure of angle 1 is equal to 69 degrees. Again, I do wish we had a faster computer, Mr. Price. Can't keep up with the board when I'm recording. Too much slower. Yeah, that's true. And if I write slow, it writes better, doesn't it? If I'm in a hurry, it doesn't. So now what's measure angle 2? Same as angle 1, right? 69 degrees. Okay? Any questions on that problem? Probably the trickiest part of it, and I know you might deny it, but the trickiest part of some of these is the fact that you're not looking at it the way you would like to look at it. And sometimes you don't even realize that's the problem, and so you don't try to rotate things around. So I'm going to caution you, if it's not sitting the way you normally look at it, rotate your book around and look at it the right way. Okay, number 8. What shape is this? It's a kite. What's true about kites? Diagonals are perpendicular. Okay? So that means angle 1 is, measure angle 1 is equal to 90 degrees. Okay? Now, here's a rule that we always taught in our other book that this book doesn't cover. And I really think it's important for you to understand. So I'm going to tell you it anyway. Move this out of the way. Group these together. Okay. This long diagonal right here is called the symmetry diagonal. Okay? The long diagonal is called the symmetry diagonal. What that means is everything on the left side of that line if folded over the line, would match up exactly on everything on the right side. So the left half of this triangle is exactly, or the diagonal, I'm going to try again. The left half of the kite, which forms this triangle, is going to be exactly the same as the right half. So if we now apply that information, then angle 2 here is going to be exactly the same as this angle over there. So if this is 90 and this is 22, what's that going to be?
68.
There are two different answers, 67 and 68. What do they have to do? They have to add up to 180. So 90 plus 22 plus measure of angle 2 has to equal 180. So if I combine those, is that 112?
That's not 22.
Yeah, it's not all me. If I subtract 112 from both sides, do you agree it's 68?
Yep.
Okay. 68 degrees.
It looks like
Okay? Alright. Oh, you thought that was a 3?
I thought it was a 3.
Oh, okay. I see. You can't add, so you blame the writing. I get it.
I was only off by 1.
Yeah. If you'd only had one more figure, if you'd taken your shoe off, you could have got it. All right. Any questions on this example? Number 14. Oh, and here's that rule. If you didn't write it down, now's your chance. The long diagonal of a kite is also the symmetry diagonal.
Oh, I just put a side note on there.
No, that's great. And I just wanted to make sure that you were aware of it, and if you didn't write it down the first time, you should do so now.
Can you read off these numbers?
Yeah, I don't even think that's my writing, to be honest with you. But this angle here is 38 degrees. This is angle 3 down here. Angle 5, 53 degrees. Angle 1, angle 2, and angle 4. I should do this. So what's measure of angle 3?
38.
38 degrees. What's measure of angle 5?
53.
53 degrees. What's measure of angle 1? 90, because those diagonals have to be perpendicular. So how do I find measure of angle 4?
90 plus 53.
90 plus 53 plus measure of angle 4 equals
180.
180. So if I combine 90 and 53 and do what? Subtract from 180, I get, what was the number? 37. Okay, and that was angle 4. I'm going to make a suggestion. If I have a triangle, then the 3 angles add up to 180. Do you agree with that? If one of those angles is 90, would you agree that the other 2 angles add up to 90? Right? So if you have a right triangle, you don't always have to add them up to 180 anymore. These 2 angles have to add up to 90. So it'd be simpler just to say 53 from 90 is 37. Would you agree? Okay. So I'm not telling you have to do it that way, but many of you are beyond this. I got to show, add the 3 numbers, A equal 180, and show all the tedious steps to that. It's much quicker if you realize, hey, that's a right triangle. That's 90, so the other 2 have to add up to 90. And same in this one. It's a right triangle. That's 90, so these 2 have to add up to 90.
52.
So if one of them is 38, then measure of angle 2 is going to equal
52.
52. Okay? Any questions on that one? And I think this is the last one. This is an isosceles trapezoid. What's true about the diagonals? They're congruent. So what do I write? So x minus 3 equals x plus 1. Subtract x from both sides, add 3 to both sides, x equals. Subtract x from both sides, I get x. Add 3 to both sides, I get 4. So x is equal to 4. Now, be careful. Some of these I may not have, like this one here, they might not have said find x. They might have said find the length of RT. Which would mean then now that I know what x is, I go back here and say RT is 2 times 4 minus 3, or 8 minus 3, which is 5. Okay? So just make sure you answer the question. It might simply be find the value of the variables, but it might not be. Alright? Any questions on that one? Okay. Today's assignment then, and again I moved the quiz over to Thursday. We're doing 6-5, 1 through 35 odds. Some of them will be very quick, like these problems. Some may take a little more thinking time. I want you to try to get this done, get caught up on anything you don't have done. This is the last lesson of the chapter. Remember, we're skipping 6 and 7. 1 through 35 odds. Okay? Practice test tomorrow after the quiz. Work day on Friday, and Monday's the test. I know we try to avoid Monday test days, but that's the only way to get the 8 lessons from 7 in before Christmas, so we're not rushed after Christmas. Okay?